Hi guys, Zimtown here. I'm a new Unity developer and I've been doing a lot of tutorials and learning in Unity recently, and what I find with a lot of tutorials online is that they will teach a topic through some kind of use case, and I find that they don't go into a lot of detail about what a given function actually does and how it works in its simplest form, and therefore when I go to transpose it for my own use case, it's not easy to do. So I thought as I learn new things, I might put together a couple of tutorials that are a bit more of a deep dive on the fundamentals of a function or small set of related functions, and hopefully that would help you guys like it has me. So the first video that I'm doing today is a video on raycasting and a few functions that will go hand in hand whenever you want to do raycasting, in particular in a 3D environment. So first up, I have a scene that I've set up. Now, setting up this scene is not an important part of this lesson. All I've done is use ProBuilder to put a few objects in. For example, some stairs, background, some squares, and a floor, just to show off a few of the things I'm going to cover in the tutorial. Now, the functions that I'm going to cover are the ray itself and a raycast collision detection, and I'm going to cover input mouse position, because then you can start to point your ray around the screen, and hand in hand with that will be screen point to ray. And at the end I will sort of bring it all together and give an example of how you could use it to, say, create the effect from Due Process, that indie development game that's kind of like Siege, where you can draw on the map your plan to have your team execute breaches and whatnot. Won't be exactly like that, but it'll be the first steps in towards making that. So a couple more things about my scene here. I've just created a prefabs folder and a scripts folder where I'm going to be creating the objects. I won't go into certain aspects because I want to try and focus on a given thing in this tutorial. There are plenty of videos and tutorials out there that cover Unity basics, so you're probably better to look at those if you have no Unity experience at all. The first thing I'm going to cover is what is a ray. By the name you can tell that it's going to be something similar to perhaps a light ray, and from that in Unity we can see that a ray is effectively a beam that has an origin and a direction that it's going to shoot out. You can also add various other things like maximum distance that it will travel. So if I go into my scripts folder, the first function we're going to look at is raycasting, or creating a ray. So I'm going to create a new script in my scripts folder, new C# script, and I'm going to call it a ray. Open this up. And I'm going to get rid of the start method for now because I don't need that right at this second. So I'm going to create a new ray, and I'm going to just call it ray. And a ray takes in, as you can see, an origin, a vector 3 origin, and a vector 3 direction. So what I'm putting in is the transform of the object of which this script is going to go for the origin, and for the direction that the ray travels I'm putting in transform.right, just to have it shoot out the right. So let's save that and see how it goes. So let's drop this ray script onto this cube here. So we'll hit play and we'll see what happens. So basically it doesn't look like anything is happening right now because a ray by itself is not visible. So let's pause that, go back into the script, and we need to add, to see it in the editor, what's called a debug.drawRay. So when you use debug.drawRay, again you're taking in the origin of the ray and the direction, and then the maximum length of the ray that you want to shoot it out, and the color. So I'm going to create a new variable called ray length. Make it a public variable. And we'll set that to 100. So this will be a variable that we can interact with from the editor and change to see how that works. So let's just save that. So for this debug.drawRay, I'm passing it ray.origin and ray.direction, so that gets that information from where I set it earlier, but it pulls it from the ray object itself, or from the ray variable rather. So let's go see how that works. So now you can see that I have this beam or ray shooting out of my square, and you notice it doesn't go forever because I set a ray length to be 100. So that's 100 in-game units. And if I look at this, I can change that ray length with the public variable I set here. So let's set that to 10. So that can be useful when you want to limit, say, the range of that a bullet can travel, or various other things like that. So I'll set it back to 100 because that's pretty useful for what we're going to be doing. The next thing I want to show you is the Raycast.hit functionality for detecting when a raycast collides with an object that has a box collider, or rather that when it collides with a collider. So for that I've set up this second square, and it also has a collider. So we're going to look at what happens when the ray collides with that box. So jumping back here, we're going to need a couple of things. We're going to need a raycast hit variable, and that will be a variable that stores details about collisions for the ray. So that's raycast.hit, and I'm going to name it hit. So the next thing we're going to need is to utilize the physics.raycast function, and that is a Boolean function that returns true under certain conditions. So I'm going to paste in that here. So let's go over this. So I've got an if statement, and I've got physics.raycast, and physics.raycast has quite a few overloads, but we'll go with the basic here. You can see it takes in again the origin and the direction, and it takes in the distance and then a layer mask. This is a bit new here, so we're going to need to create a new variable to cover this layer mask. So again, I'm going to create another public variable, a public layer mask variable, and I'm going to call it layer mask. Nice and easy. And I'll show you how that works when we go back to the editor. But what this effectively does is it limits what the raycast can collide with to a certain layer. And you can then choose that in the editor if you set this to public. There are other ways to do this, but this is the one I'm covering here. So I'm going to draw a second debug.drawRay, and I'm going to use this to show you how a ray can collide with the surface of an object. In this case, again, I'm taking the origin and the direction, but I'm multiplying it by the distance. Now, the hit.distance, our raycast hit, what hit.distance is the length of the ray before it collides with a collider in the layer mask. So, and I'm going to get it to draw it in blue, so it'll be visible over the top of the other ray. So I've got a few other things in here that I'm going to print out to the console. Firstly, I'm going to print out that we hit something, and obviously this only occurs on the condition that we actually hit something. So I'm going to take hit.collider.name. So hit has in it the ability to grab the name of the collider that you hit with. So I'm concatenating that into this string here, and I'm saying at hit.point. Hit.point is a vector3 position in the world. It's a world position, and you can see it's got .point as a property, so I can just retrieve that details through hit.point, and I'll show you what that does. So if we come over here, we can see the layer mask, the public layer mask that we just created. We need to change this from nothing, because we don't want it to detect nothing, to everything. So things that are in the, well, in all layers that have a collider will now be detected. So if we hit play, we'll see the ray shooting out. So currently it's yellow, because the collider has not collided with anything, or the ray has not collided with anything. But as we move it across this other object that has a collider, you can see now the blue ray starts shooting out. And because it's written after the yellow ray, it overrides it, and we get to see this trajectory that it would have taken, but also the new ray just travels to the surface before it's hit. And we can see in our console that we're printing out the name of the object of what we hit.short or short1. So this is just a copy of this short object that I made. And you can see that it's showing the collision location. And if we were to move the object, you can see that that's updating the position at which this blue ray is hitting the collider. So now we can detect the position that a ray hits, which is very useful for various things. So the next script I'm going to create is just a really short one, and it's going to be input.mouse position. I'll just do this really quickly because it's going to be useful for getting a ray to shoot out from the screen, but this will help you understand what's happening. So let's just do mouse pos as our script name. So again, we're not going to need the start method for this particular use. I'm just going to be doing a debug.log in this case, and I'm going to be printing out input.mouse position. So input.mouse position gives you a vector 3 of the position on the screen that the mouse is. So for example, looking at my screen here, 0, well, we can think of this as a Cartesian plane, and you break up every single pixel into a value from 0 to whatever your screen resolution is. So if I was, and the other thing to remember, it starts in the bottom left corner. If I was to put my mouse in the very bottom left of the screen while in play mode, that would be 0, 0. And then up from there is up in the y-axis, and right from there is up in the x-axis. So let's put this on an object and just see how it goes. So what I'm going to do first, I'm just going to remove the ray script so that our debug console is not too filled, and I'm going to use this game manager object I created in the beginning, which is just an empty object with the name game manager, so I could drop scripts like this in. So I'll drop the mouse pos script in there, and then we'll hit play and go to the console. Now as I move my mouse around the display, you can see how the numbers change, and as I move towards the bottom left of the screen, you'll see both values decreasing towards 0 as we get to the bottom left. Now if I move up the screen, you'll see that the Y value is increasing, but the X stays the same so long as I keep my mouse on the left. But if I bring that down to the bottom left corner and then I move my mouse to the right along the bottom of the screen, you can see the X increasing. So it's just a Cartesian coordinate that represents where your mouse is pointing on the display. That was fairly simple, but we're going to be using that in the next script that I want to create. Is going to be screen point to ray. So I'll create a new C# script and I'll just call it screen ray. We'll just open that up. Screen point to ray is going to utilize a camera object and the ray to create a ray from a position on the screen, or on the camera rather, to a direction in the world. So the first thing that we're going to want is a camera variable. So I'm just going to create a private camera, and I'm going to reference that in the start method. And you can reference your main camera with this function here, camera.main. It's a pretty easy way to grab your camera when you're first initializing the object. Note this will grab the current main camera at the moment that this initializes. The next thing we're going to need is another ray. So the first thing I'm going to do is use the screen point to ray, and you have to do your camera object dot screen point to ray, and then a position from which to shoot on the screen. So you can think of this as the starting position on the screen. So I'm going to need another variable. We'll make this a vector3, just an example variable to show what happens when you shoot it from a set position. So let's create a new vector3 called pos, and I'll just set it to 400, 400. So 400 up the x and 400 up the y. And that's where, from the position on the screen from where the ray is going to shoot. So I'm going to need another debug.drawRay, and this is going to take the ray origin, which is the position we just set, 400 by 400 pixel on the screen, and its ray.direction is directly out from the screen. So whatever is under that pixel in a straight line is where the ray is going to go. And we're multiplying that again by ray length. So let's just chuck ourselves in another public variable for the ray length. And then again, we're setting the color to yellow. So let's see what happens when we do this. So I'm going to add this script to the screen, to my game manager again. I'll get rid of the mouse pause script for now. Okay, and then let's hit play. So now we can see that there's a ray coming from the camera, and 400 by 400 is somewhere down in the bottom left of my screen, so you can see that it's shooting out on a leftward angle. So that's how you get a ray to shoot from the camera into the scene. So now let's explore shooting a ray from where your position is on the screen using our recently discovered input.mouse position instead of just a set position on the screen, and that will allow us to move the ray around. So let's go back here. We'll leave that ray there. We'll create a second ray. So now we've got the same type of function. We're using cam.screenPointToRay still, but instead of setting it a predetermined position of vector3, we're taking the input.mouse position vector3, which we saw earlier, prints out the pixel that the mouse is currently pointing at. And if you think about what the original ray we just used did, screen point to ray at position, that was just defining a pixel. Now we're getting a pixel based on the mouse's input. So let's draw this one. So let's draw this second ray using another debug.drawRay. We'll pass it this time ray 2's origin and direction, and ray length, which we set as our public variable of 100, and we'll set it to blue. Save that, wait for that to compile, and we'll hit play. Now what you can see, actually let's move the camera around. So we have our original ray heading down to that 400 by 400 pixel, but now we have the second ray that changes direction based on where my mouse is moving in the display. So now I have effectively a laser pointer that I can control and point at things. So I want to point at the top of this cube, I want to point it there or over on this object, and now we can start to do things based on where the mouse is pointing in the scene, because you can see that you can cause it to collide with whatever you're pointing at. So I'm going to add some functionality to the script to add what we learned earlier about the ray and how you can detect what it's colliding with and where, to show then how this could be used with the screen version of a ray. So we're going to need to build another Raycast. We might just get rid of this ray here because we don't want it quite like that. So we need to build first another Raycast variable, Raycast hit variable, and we'll call it hit, and then we're going to use the physics.raycast function boolean to determine if we hit something, and then do something based on whether we hit it or not. So what have we got? Oops, we've deleted our second ray. I need to create that again. There we go. So we've got our ray back based on our mouse position, and we're checking if the ray that shoots out in the given direction at a given length hits anything in the layer mask. So we're going to need to create that layer mask again. So I'll grab that, and we'll chuck the variable up there, make it a public layer mask, like so. Just call it layer mask again. And then we're going to store anything that we hit at, any colliders we hit, in the hit Raycast hit variable. And we're going to print out a new ray only if we hit something. So we'll still be, again, printing out the yellow ray, and then the new ray will print out on top of that only at the distance to which it hits the collider. So the blue ray will only exist up to the object. And then I'm going to, again, print out just a log of what the intersection point is, the vector 3 in world that the hit occurs. So let's see how that looks. Before we start, we need to again change the layer mask. Actually, I'll show you what happens if you don't. So if we hit play and I move my mouse around, well, nothing. So let's change the layer mask to make sure it can hit everything. Hit play, and now we have both our little laser pointer, and the console output is showing the object name, or actually in this case it's just showing the hit point because I didn't set it to print out the object name. So, but this is giving us a Cartesian coordinate or a vector 3 of the exact point at which it hits the object, or at least the object collider. So what I talked about in the beginning was adding the functionality of the game, the indie game due process, where they're looking from a top-down view onto a map, and the leader is able to draw the plan on the map. So to be able to do that, firstly, you obviously need to be able to detect where you're pointing, which is what we've just achieved with our Raycast and our screen point. Now we need to determine how to create an object when you want to draw into the world, into a 3D world, because it is a 3D display that they have in the due process game. We'll create a new C# script. This time I'll call it create at point. As we're going to need quite a bit of what we just used, or what we just created with screen to ray, we may as well just go and grab what we've already created. So I'll grab all the variables and all the functions. We'll paste that in. So we're definitely going to need our camera, our ray length. This is optional. You could say have infinity length, but I prefer to limit the length of the ray for various reasons. And we're going to need our layer mask again to determine what you can and can't hit. And what else are we going to need? We're going to need an object to create. So what we're going to do is instantiate a prefab. So I'll just duck back to Unity, and I'll show you how to just quickly create a prefab that we can use. Let's just create a new 3D object called a cube. We'll create a cube rather. Let's create a new tag. Why I want to create a new tag is because I want to set conditions on where the cube spawns, because if you remember in the game, the cubes don't spawn on top of each other or in walls or certain things, and they form a mini grid and they're slightly separated as an even distance from each other. So let's add a new tag, and let's call this tag do not build. So let's go to our object that we just created, and let's tag it do not build. So now I'm just going to drag this into my prefabs like that, and then I can delete it out of my scene. So that's going to be the object we create. Actually, one more thing, this will be relevant later. I'll just change the size of it to 0.75 in all directions. Just makes it a bit smaller. And if you didn't know, in Unity, when you're updating a prefab and you want it to apply to all prefabs of that type, you can just hit apply all under the overrides drop down. So now we can delete that one. Yep, and you can see my prefabs 0.75 across the board. Let's go back to our script. Now that we've created our prefabbed object, we need to reference it in our code. So we're going to use a public game object, and I'm going to call it prefab. So then we'll be able to drag and drop whatever prefab we like into our game object reference, and that will spawn at the end of our ray. So now that we have our prefab, we need some conditions in which it will spawn. So firstly, we obviously want it to only spawn if it makes a collision with an acceptable layer. Secondly, I want it to spawn when I press the mouse. In the game, they sort of click and drag by the looks of it, and it draws kind of a line, a dotted line, wherever they're drawing. So what I'm doing here is I'm making a condition if get mouse button 0. That means while the primary mouse button or left click mouse button is held, when it's get mouse button, it's when it's held, not so much just pressing it. Like if you just press it once, this will continue to be true for every frame in update. So, and then I'm also setting a condition that our hit variable and its .collider.tag does not equal do not place, which is, if I got it right, the name of our, I said do not build, so let's change that to do not build. So we want to make sure that we're pressing the mouse and the collider isn't registering do not build to be the tag. So here we want to create a new vector3 called prefab spawn, and in that we're going to store hit.point. Now you could use hit.point directly, but I want to make some slight modifications to the position that is returned. So I'm just going to store it in a vector3, and then we're going to add a little something to it. So what I'm doing, I'm adding to the prefab's Y position, and I'll show you why I need to do that. So let's just comment that one out. In fact, we'll just comment all of these out so we can see what happens to start with, and then I'll explain what's going on here. So I'm going to be calling the instantiate method, which will, as it sounds like, instantiate an object, and it will instantiate it at a vector3. And if you like, you can add a quaternion, which is a rotation variable. And I'm doing quaternion.identity, which is, I believe, just the rotation that the prefab has. So let's just save that and see how it works as is. So we're saying if mouse button 0 is down and the collider is not do not build, then instantiate these prefabs. Now, do we have that script on? No, so we'll remove this previous script and we'll just put in create at position onto our game manager. And we need to drag in our prefab. So we'll drag our cube in and set the layer mask to everything. And we'll hit play. So we can see our ray moving around, and now if I hold 0, you can see that objects are being created wherever I draw the mouse. Now, I'll just unpause that. We set one of our conditions to be do not build. So let's just set a few things as do not build. We'll leave that one as untagged, this one as do not build, set this one as do not build. And let's set this back wall as do not build. So let's hit play. And now, so if I try to click on this object, it won't build there. It will build all around it, but not directly on it. Whereas if it doesn't have that, you can see it builds up onto it. So I can build up the stairs, up here, but I can't build on the wall. I'm still holding the mouse button down, but nothing's working. So the other thing you notice is that the squares are in the ground. Now this is why I wanted to modify the hit.position rather than use it straight out of the box, as it were. Let's go back to the script and let's do that. So here, I'll uncomment this, and I'm modifying the Y by a prefab offset. So let's create a public variable for that. Okay. So I'm just creating a public float so that I can modify it if I need to. And I'm just going to set it to 0.05. That's half a normal cube size of 1. So also remember that our cube is slightly reduced in size as well. So now I'm saying I want the Y value to equal the Y value plus our preset float that we've just set of 0.05. So hopefully instead of halfway in the ground, it should be just slightly floating above the ground. Let's have a look at that quickly. Hit play. There we go. So now our object, instead of being embedded in the ground, if we take a closer look at this, is hovering just above the ground. So now the other thing about the game's system is that objects are not smushed together like this. So they're evenly spaced in a grid. So let's look at how we could make this spawn only in a separated grid. We'll go back to the code. So what I'm doing to achieve that is I'm converting all of the values into integers, because by having the cube shrunk down to say 0.75, if the cubes can only spawn at a variable of an integer, they will be slightly separated. So I need to convert every single part to an integer. Also you need to add using.system to convert to integers. So let's just chuck that in our using. So for example, a value of like an x value of 0.25 will, through convert to integer, will be reduced back to the closest integer. So it'll become a 0 in that case. And the same occurs in every direction. So you then get objects that are placed in very specific intervals. So we'll go and have a look at how this looks. So now when I drag my mouse, it doesn't draw. I'm holding the mouse down right now. Firstly, it's not drawing on itself, but it doesn't draw until it hits a new integer. So now when I draw, I get this very sort of interesting grid pattern, kind of like what's in the game. So now I can draw up and down the stairs and have it look like the effect in the game. Obviously the game utilizes some instantiation visual effects for the cube, and when you play the game it actually draws the equivalent route down on the texture for you. I won't go into that here, but this gives you a starting point for creating some interesting effects. So I think I'll end this tutorial here, and feel free to go into the comments and let me know all the things that I've done wrong. As I said, I'm a beginner at Unity still. I just wanted to share some of the things I've learnt in a format that I'm hoping will be helpful to people like me that need a little bit more information about a given function to really understand how it works. And if people like it, as I learn new things, I'll create new tutorials and create a series for Unity. And feel free to let me know all of the things that I missed, and it would be helpful for me to learn as well. Thanks, and I'll see you all next time.